Welcome to the Priva Compass hardware training. In this presentation, we will be showing an overview of the hardware components of the Priva Compass. In this presentation, we will be covering several different subjects. First, we will look at the different cabinets that we supply. Next, we will look at the various features of the main controller in the cabinet, covering the type of cables you need to use and how sensors can be connected. Then we will explain the expansion modules that you can add to the compass. After that, we will show how these need to be connected in an I/O bus network. Finally, we will discuss how to connect multiple compasses within an industrial Ethernet network. The compass lineup consists of 2 smaller and 2 larger panels. The Compass 2S and 2X are smaller panels, measuring 500 by 500 millimeters or 20 by 20 inches. And the Compass 4S and 4X are slightly larger at 600 by 600 millimeters or 24 by 24 inches. Later in this presentation, we will delve into the distinctions between the S and X models. When we open the panels, we can see the difference between the 2S and 4S variants. The Compass 2S and 2X panels contain a controller. And there is room in the panel for 3 small expansion modules. The Compass 4S and 4X panels contain a controller and 1 large expansion module. And there is room for 6 small expansion modules. Let's take a closer look at the Compass 4S cabinet. It's worth noting that the panel shown here is the European version, compliant with CE requirements. An American version, compliant with UL and CSA requirements, is also available. Although they are quite similar, some of the components are different or will be in different locations. Before reviewing the panel's components, let's discuss the holes at the bottom of the compass. Positioned there for a specific purpose, these holes encourage the installers to feed all the cabling through the bottom of the panel. We are always concerned about moisture entering the panel, given the high humidity typical in greenhouse environments. By directing cabling through the bottom of the panel, natural drip loops are formed in the cable, preventing condensation from entering the panel if it builds up along the cables. This practice should apply to all electrical wiring installed in greenhouses. The incoming power for the Priva compass can range from 100 to 230 volts AC, depending on the local power grid. This power can be connected to the terminals on the bottom left of the panel. We have provided a circuit breaker to allow you to disconnect all power from the panel if needed. We should also mention grounding at this point. Depending on where you are in the world, you may call it earthing instead of grounding. Proper grounding of the panel is needed for adherence to local electrical codes. Also, instances of erratic behavior between the compass and the different sensors have been traced back to improper grounding, underscoring how important it is to properly ground your equipment. Later, we will talk about proper grounding of shielded cables. These terminals can be used to connect the shields. In the panel, you'll find an AC transformer which can supply power for your field wiring. It is a multi-tap transformer. When you are installing the compass, make sure you select the proper tap depending on your supply voltage. Since much of your external control wiring is 24 volts AC, you want to be sure that you have the proper voltage feeding it. If it is too high, equipment will burn out, and if it is too low, there will not be enough power to energize the equipment. This transformer is protected by a 4 amp fuse and can deliver 100 VA, typically sufficient for most installations. Should additional power be required, external transformers can be installed outside the panel. The panel also contains DC switch mode power supplies, one for powering the compass and another for your field sensors. We use separate power supplies to provide isolation. If there is a short in the field wiring, the voltage may drop on the power supply for the field devices, but we will not lose the power for compass. You also need to keep this in mind if you use the power supply for multiple devices. Let's say that you are using the power supply to power both the weather station and a water tank level sensor. If there is a short in the water tank level sensor wiring, you will also lose the power to the weather station. Tucked away in the bottom corner is an alarm buzzer, alerting nearby individuals to high-priority alarms within the system. I mentioned earlier that there is a difference between the 2 and 4S versions, as well as the 2 and 4X versions of the panels. The difference is that the S versions of the panels contain a gateway, mounted on the door of the panel, while the X version does not have it. But what exactly is a gateway? Acting as a bridge between the compass system and external communication networks, the gateway serves 4 main functions. It is a web server for the user interface access for the grower. It is a web server for configuration screens for the installer. It is a gateway for the optional cloud connectivity, enabling remote access from anywhere in the world. It contains storage for 2 weeks of historical data for all connected Compass units. We will cover the gateway in more detail later. Next, we'll examine the main controller, the CMX34, which serves as the system's nerve center. Why do we call it the CMX34? The C indicates that it is the main controller, and the MX34 means that there are a mixture of inputs and outputs that add up to 34. Let's go over the various inputs and outputs available on the CMX34. First, we will look at the 8 universal inputs. These inputs can be connected to voltage, current, or resistance sensors. When connecting sensors that supply a voltage, the allowable range is 0 to 10 volts DC. When connecting sensors that supply a current, the allowable range is 0 to 20 milliamps. When connecting sensors that supply a resistance, the allowable range is 0 to 30 kiloohms. There are also 12 digital inputs. These can be used to detect a status feedback based on a normally open or normally closed contact. They also can measure pulses to allow you to connect to different flow sensors. For flow sensors, we recommend the Signet paddle wheel flow sensor. The sensors need to be connected between the input channel and the field ground. The 6 field ground terminals are used for universal and digital inputs as well as analog outputs. Since there are more input terminals on the CMX34 than there are field grounds, we have added extra field ground terminals for you in the bottom of the panel. For the modules that come pre-installed, we have already connected a wire from the field ground of the module to the field ground terminals at the bottom of the panel. If you are adding more input modules, make sure that you connect the field ground of the module to the field ground terminals. When selecting cables for universal and digital input connections, Priva recommends wire with a minimum diameter of 0.8 millimeters or 20 gauge. Another item you need to keep in mind is the maximum cable length. For Priva sensors, the maximum cable length is described in the installation manual found on our support page. For other sensors, check with the manufacturer of the sensor. If you cannot find the information from the manufacturer, use the rule of thumb that if the installation requires a wire run of more than 100 meters or 300 feet, we recommend either doubling the number of wires or going to a thicker wire. For sensors connected to the compass, the cable must have a shield. This will protect the measurements from being influenced by electromagnetic noise caused by other equipment in the greenhouse, such as variable frequency drives. When using shielded cable, you always need to make sure that the shield is connected to earth or ground at only one point. If you connect the shield at both ends of the wire, there is a chance that the earth or ground potential is different between the 2 points and a current could pass through the shielding, causing electrical noise or damage. If you do not connect the shield at all, you will lose some of the effectiveness of the shield. The ground strip located at the bottom of the panel ground strip that we mentioned earlier can be used for connecting your shield to ground. When connecting your inputs, you also need to determine whether to use a stranded or solid cable. If the wire will not flex or change positions after it has been installed, you can use solid wire if you want. But if the wire can move after installation, it needs to be stranded flexible wire. For instance, let's think about the compartment temperature and humidity sensor. The grower wants to control the environment based on the conditions at the crop level. As the crop grows, they may adjust the height of the sensor so that it continues to be at the crop level. To keep the wires from becoming brittle and breaking after a few years, you would want to use flexible or stranded wire for this part of the installation. The sizing of the cable also comes into play when you are connecting the cables to the push-in terminals on the compass. Let's first look at what you need to do with stranded wire. If you are using stranded wire, you will need to use ferrules to bind the wires together to both ensure there are no stray strands of wire in your installation and to properly insert them into the push terminals. For a single stranded wire, you can go as large as a 14-gauge wire or 2.5 square millimeter wire. The ferrules must be at least 10 millimeters long so the push terminals can get a good grip on the ferrule. If you want to have 2 stranded wires on one terminal, you can only go up to 16-gauge wire or 1.5 square millimeter wire. You will need to use double ferrules that can accept 2 wires, and these ferrules must be at least 12 millimeters long instead of the 10 millimeters that you used for single-stranded wires. For solid core wire, you do not need ferrules, but you can only put 1 wire into the push terminal. The wire can be between 0.2 and 2.5 square millimeters or between 25 and 14 gauge. Make sure you strip at least 10 millimeters or 0.4 inches so that the push terminal pushes against the wire and not the insulation. While we are talking about the type of cables that you need to use, make sure you always use UV-resistant cables in the greenhouse. Also, if you are using cable ties anywhere in your installation, you also need to make sure they are UV-resistant. If you do not use UV-resistant cables and cable ties, they will break down after a few years in the sun. Now let's get back to our compass controller and have a look at our digital output relays. There are a total of 8 relay outputs on the CMX34. Outputs 1 through 5 have normally open relay contacts, and outputs 6 through 8 have both normally open and normally closed contacts in case you need that option. The current ratings for the relay contacts are located in the installation manual. Although the ratings do in theory allow you to connect the compass digital outputs directly to some field devices, please do not do it. The relays have a mechanical life of about 300,000 operations, but the electrical life is less if you put a lot of current through it. Instead, connect your relay output to an interface switch that allows you to manually control your equipment. From the interface switch, you can add a contactor that has the proper voltage and current rating for the device you are controlling. You connect your field device to the contactor. One important advantage of this is for troubleshooting. If someone is trying to figure out why some field device is not working, they can go to the interface switch and manually turn on the device. If the device does turn on, you know that section of the circuit between the interface switch and the field device is good, and the problem is most likely between the controller and the interface switch. A controls technician can then troubleshoot further. If the field device does not turn on, the problem is in the section between the interface switch and the field device, and an electrician can troubleshoot it further. One of the few times we recommend connecting field devices directly to the controller is with irrigation valve solenoids that do not draw much power and has a manual control right at the valve that you can use to operate the valve. Even then, you need to be careful. If the cabling is short, you should not see an issue. But if you have a long cable run, you will see some voltage drop across the cable. This is because the solenoid can draw a decent amount of current, and the longer the wire run is, the more resistance there is along the cable. The result is that there may not be enough power to energize the valve. So, what size cable should you use? If you are controlling small solenoids and the cable length is short, you might be able to use the same 0.8 mm diameter, 0.5 square millimeter, 20 gauge wire that you used for the sensors. But every installation is different. Your best source of information regarding the proper size of the cable is usually your cable supplier. But for them to give you good advice, you will need to let them know about your installation. You will need to let them know the voltage you will be using. They also need to know how much inrush current the devices draw when they are first powered up, and how much holding current the devices will draw when they are continuously energized, and how many devices will be energized at the same time. And of course, you will need to let them know the cable lengths you will be using. Based on that information and the local codes, they should be able to give you a recommendation. Why is this important? If you install cabling that is too small, you will only realize the problem after the installation is complete, which means that you will have to replace the cable. It is always better to be absolutely sure that the cable is the correct size ahead of time. Once again, going back to the controller, we also have 6 analog outputs on the CMX34. The first one is reserved for the alarm buzzer we mentioned earlier, but the other 5 are free to use. They can provide an adjustable 0 to 10 volt DC signal. You should note that the outputs can only provide 5 mA, so you cannot drive field devices that require a 4 to 20 mA signal. Once again, check the specifications on the device you are connecting to determine if a shielded cable is necessary. If you are in doubt, use a shielded cable. It is better to be safe than sorry. Additionally, a dedicated alarm output relay provides both normally open and normally closed contacts. The relay is energized when there is power applied and there are no high-priority alarms. The output will de-energize if there is a power failure or when the high-priority alarm is present. These alarm relays are interconnected so that if you get an alarm in one compass in your network, all the alarm relays in your entire network will activate. This means that you can tie your alarm system to any compass in your network. The communication port gives us connectivity with smart external devices such as weather stations, utilizing the Modbus protocol for data exchange. There are a few items to note when connecting the WSC-11 weather station. The WSC-11 comes with 15 meters or 50 feet of cable. The communication wires can be directly connected to the communication port on the compass. But remember how we mentioned that the compass has a separate 24-volt DC supply for field devices? This is one example where you will use that supply to power your devices. Also, since this is a shielded cable, make sure you tie the shield to the earth or ground strip at the bottom of the compass panel as we discussed earlier. If the 15-meter or 50 feet of cable is not long enough, you can extend it, but you will need some additional equipment. I will not go into that here, but for information on that, check out the article on How Do I Connect My Weather Station in the Installing Your Hardware section of the Priva Help Center at support.priva.com. The WSC-11 weather station comes with a mounting bracket. When installing the weather station on the mounting bracket, make sure that the set screw is facing north. This is important so the weather station can interpret the wind direction properly. Coming back to our compass controller, let's look at the 4 network ports on the CMX34. These ports allow the compass controllers to communicate with each other and with the gateway. We will cover this network a little later. There is one last item we will briefly cover on the CMX34, and that is the I/O bus port. Although it looks like just another Ethernet port, it is not. The I/O bus port is used to communicate between the different I/O modules on the same controller. We will also cover this in a little bit. Now we will have a look at the expansion modules. The first one we will cover is the MX34 expansion module. This is only available in the Compass 4S and 4X panels, and is what differentiates them from the Compass 2S and 2X panels. This module looks a lot like the CMX34 module, but there are some differences. First, there is no reserved analog output for the alarm buzzer. This means that you are free to use all 6 of the analog outputs for field wiring. Also, there are no alarm outputs. No RS-485 communication ports, and no Ethernet ports. What it does have are 8 digital outputs, 8 universal inputs, 12 digital inputs, and 6 analog outputs. As you can see, this module gives you a nice mixture of inputs and outputs that you can use. The way the inputs and outputs are configured are identical to the CMX34, so all information we covered on the CMX34 module are also applicable here. You may have noticed there is one item that is not on the CMX34, and that is the extra I/O bus port. As I promised earlier, we will be discussing the I/O bus in a little bit, but I want to introduce the last 2 I/O modules first. These are the UI8 and DOR6 modules. Let's start with the UI8 modules. As the name suggests, this module has 8 universal inputs. These inputs are identical to the inputs on the CMX34 that we already described. Remember how I talked earlier about connecting the field grounds when we discussed the CMX34? If you install UI8 modules in your panel, you will also need to connect the field grounds to the terminals in the panel. The last module is the DOR6 module. Each module has 6 relay outputs. 5 of the relay outputs have normally open terminals, and the 6th one has both normally open and normally closed terminals. Now we will have a look at the I/O bus network. Finally, let's get to the I/O bus that I kept mentioning. This I/O bus is how the controller module communicates with the expansion modules. If you have a Compass 2S with only a CMX34, it is easy. You don't have to do anything because there is only one module. Now, if you want to add an extra UI8 module to your compass, you simply snap it in under the CMX34 and plug in the I/O bus jumper that came with the module. You can connect up to 3 different small I/O modules to the CMX34. You can add UI8 modules and DOR6 modules in any order that you want when you first set it up. However, once you start programming the I/O modules, you do not want to switch them around. If you have a Compass 4S, it comes with both the CMX34 and the MX34 pre-installed. The I/O bus cable is also already pre-installed. You can add up to 6 different small I/O modules. Move the I/O bus cable from the CMX34 to the bottom module in the first row. and add the I/O bus jumpers that came with the modules. Your compass also came with labels for the modules. Stick them on the modules and place them in the same order that you have the I/O bus cable connected. Now let's take a look on how to connect compasses to each other in an Ethernet network. If your system consists of a single compass, the Ethernet communication cable has already been run. If you are adding compass 2X or 4X panels to your system, you will need to run the additional communication cable yourself. Let's have a look at the network communication. We will start with a single compass that we described earlier. The green wire represents the Ethernet communications network cable, and you can see it goes directly from the CMX34 to the gateway. This is how the 2S and 4S panels are originally set up. Now let's add additional compasses to our network. You will notice that the original compass is no longer connected to the gateway. Rather, all the compasses in the gateway are connected to each other via an industrial Ethernet switch. This is the preferred solution when all of the compasses are in the same building. Keep in mind that you will need to follow Ethernet rules, which maintain that each Ethernet cable must be less than 100 meters or 328 feet. If the compasses are in different buildings, or if the distance is more than 100 meters or 328 feet, you will need a different solution. We recommend using fiber cable in those situations. The benefits of fiber cable is that you are not limited by the distance, and there is an electrical isolation between panels. This isolation becomes very important during lightning storms where lightning may hit one of the greenhouses. Without isolation, the lightning may find a path along your Ethernet cables and damage your equipment. Also, make sure that the Priva equipment is on a separate Ethernet network. Do not mix it with your office network. Which brings me back to the gateway. You can see that there are 3 Ethernet ports on the gateway. The middle port is for the Priva network that we just explained, and the bottom port is for your office network. This brings us to the end of the Compass hardware installation tutorial. The next training module will cover the software configuration of the Priva Compass. If you have not already done so, please enroll in our Priva Academy and sign up for the Compass Basic Engineer training. You can also check our many other available training modules. Thank you for joining us today.